This next segment is on hydraulic fracturing and drought. Recently, a lot of attention has been called to the drought that has happened here in the Midwest, and questions have arisen concerning the availability of water for hydraulic fracturing during times of drought. During the recent drought, several states were affected, including Colorado, New Mexico, Oklahoma, Kansas, Texas, and Wyoming. All of these are major oil and gas producing states. In Meade, Colorado, city-held auctions for water went from $9 to $100 per acre foot, but energy companies were buying water for $1,200 to $2,900 per acre foot. In the South Texas Eagleford play, in some locations, companies have had to go outside the core area of the play to truck water as much as 75 miles, and water prices have skyrocketed. In the Marcellus play, the Susquehanna River Basin Commission suspended 16 water withdrawal permits in July 2012 due to low flow conditions in the Susquehanna River. Recently, Devon launched a massive water recycling project in the Anadarko-Woodford Shale to connect 36 well sites and reduce their reliance on fresh water. The U.S. Drought Monitor is run by the National Drought Mitigation Center in Lincoln, Nebraska. This is a joint federal effort by the U.S. Department of Agriculture and the National Oceanic and Atmospheric Administration. It provides weekly updates for all of the United States in terms of drought condition. The next graphic shows data for last January for Oklahoma as we were coming out of a longer than 2-year drought in this area. And as you can see in the graphic, Oklahoma was under severe to exceptional drought in almost the entire state. This next graphic shows a report that Ceres put out. Ceres is a nonprofit charity organization. Their mission is to mobilize investor and business leadership to build a thriving, sustainable global economy. Their recent publication calls attention to the growing pressures for water in the oil and gas industry in areas that are under water stress. So for this series report, the next graphic shows that many states where hydraulic fracturing is most intense are also areas experiencing high to extremely high water stress. This includes Texas, Colorado, Oklahoma, and Wyoming, 4 of the biggest producers of oil and gas in the United States. Just under half of the wells developed in Texas over a period of years are in regions under high to extremely high water stress. In Colorado, it's even worse. 97% of the wells being developed there are in regions of high or extremely high water stress. In order to ensure the sustainability of energy production and access to fresh water, integrated resource management is imperative for all parties. This includes the oil and gas industry and communities. In addition, there's an issue with aquifer depletion, particularly in the central part of the United States. Many innovations are occurring to mitigate water use in water-stressed areas, such as recycling and use of other non-freshwater sources. A recent USGS report, which assesses the extent and rate of major aquifer depletion in the United States, finds that aquifers in peril include the Ogallala Aquifer in the high plains of the central U.S. and the Mississippi embayment in the Gulf coastal plain. Both of these aquifers touch regions where there is intense hydraulic fracturing activity. A legitimate question is, will water supplies be sufficient to meet U.S. energy demands in 20 years? Population could increase significantly over this time period. Fresh water will not. We have all the water we're ever going to have. Population increases will not necessarily be in water-rich regions. Climate change and energy industry operations could impact water supplies, water quality, and energy demand. Water for energy demand in terms of impacts of water withdrawals are not readily discernible on a national or even a regional scale. In terms of scale, water usage for oil and gas is almost insignificant at the national level, and for the more narrow use for hydraulic fracturing, even less so. During the recent severe drought in the central U.S., most impacts on energy were of a local nature, but these were significant enough to get the attention of the energy industry and investors. When you look at considerations of scale on a national basis, the USGS estimated national water use in 2005 to be over 10 to the 14th gallons of water. In terms of water use for mining and oil and gas, it only uses about 1% of that water. So oil and gas production is a minor user of water on a national scale compared to other sectors, such as municipal water needs, agriculture, and hydroelectric power. EPA estimates water used for hydraulic fracturing in 2009-2010 to be even less than 0.1% of total water usage. So the issue then becomes one of a local scale, and it's going to be based on local geology, local hydrology, and water needs. For instance, take the case of Colorado and Pennsylvania. This graphic shows that the total number of wells in 2010 in Colorado was almost 3,000 wells operating. In Pennsylvania, it was less than 1,400, or about half as many. The estimated water use per well in Colorado was only about 1.7 million gallons per well. In Pennsylvania, it was 5 million gallons per well. So in the end, Pennsylvania was using more than 50% more water, even though they were using half as many wells. And if you compare what they were using in those two states to the total state water use for a given year, in Colorado it's less than 0.1%, and in Pennsylvania it's about 0.2%.